Okay, hello everyone. We are now going to talk about linear separability, a concept that is important in perceptrons and machine learning in general because it allows these systems to classify things by separating them into one group or another. So the question right now is, can these sets of points be separated with a line? This is 2-space and we've got sets of points A and B. These are just Cartesian coordinates. So anything that's in the green circle, any Cartesian coordinate should be separated from any Cartesian coordinate in the blue circle. So any points in these sets should be separated. And of course, the answer is yes. You can separate these two sets of points with a line, right? And so, yeah, they are linearly separable. Let's go back to black, ink, A and B are, I'm just going to write LS, linearly separable. But you go over here and you have C and D, and all the points in C, all the points in D. Of course, they are different points. There should be some way of categorizing the C's and the D's, distinguishing them, but it's not as simple as drawing a line between them, because any line you draw that keeps C on one side of it is going to get some of the D's on one side of it, no matter what you do. And then any line you draw that tries to get all the D's on one side is going to also capture some of the C's. So there's just no way to draw a line. I'll draw some bad lines, right? These are bad lines. They don't do anything. So we don't like those. Hey, still learning, people, how to do all this. So that's not going to work, and this isn't going to work. And so, of course, C and D are not linearly separable, all right? So that's going to become important, because moving over here, we might want to capture certain functions, and these are incomplete. This is or operations, logical operations. This is OR, not XOR, OR, so it's inclusive. And we've got the Cartesian coordinates. Now, instead of blobs, circular blobs of Cartesian coordinates, we've just picked these four, right? So when the input values are 0 and 0 with OR, for remember Anne or Betty is home, and in this case neither one is home, then the statement Anne or Betty is home is also false. But how about the statement Anne or Betty is home when Anne is not home but Betty is home? Well, then it's true, because one of them is home. And down here we have Anne is home, Betty is not home, but the statement Anne or Betty is home is true, which I'm representing in this case with green. And then remember, it's inclusive, so this will be 1, come on, comma 1, and that is also true. Either Anne or Betty is home, and that's going to make the statement true when they're both home. Question, can you draw a line between these? Of course you can, right? So a line going this way would not work. A line out here would not work. A line going this way would not work, or this way would not work. But this line does it. I came really close to the blue. I almost put the blue on the other side, but no, it works. So yes, OR is linearly separable. We can show that with Anne as well. I'd forgotten that the book doesn't, I don't think the book does Anne, but we're doing it right now just so you understand how it works. So here, neither Anne nor Betty is home, so 0, 0, 1. I mean, whoops, 0, 0, 0. Okay, these are just XY Cartesian coordinates, and we've just decided to to let this be a distance of 1. This is a distance of 1, right? So over here, we're going to have, you go out 1, right? And you don't go up at all, so it's 0. And this is the AND function. So we're not doing OR. We're saying Ann and Betty are both home. Is that true when Ann is home but Betty is not? Of course not. Right? And then up here, we go out 0 and up 1, and it's AND, so it's going to be a 0. And then switch to green just to make it nice and colorful. 1, 1. In this case, they're both home, so what should it be? It should be 1. This is the only way you can make it true that both Ann and Betty are home, is to have Ann home, Betty home. Then it's 1. In every other case, it's blue. Now, is this, oh man, kind of messed up the ink. I don't know. Still learning. Okay, let's try it. Yeah, can you draw a line? Of course you can. Let's do it like that. Okay, so and is linearly separable. But not everything is, as we will see.